Well, hello, geometers and general seekers of truth. Let us approach a more complicated problem involving regular figures, in this case, a regular pentagon. So let's say we start out with a regular pentagon, and regular means all the same lengths and all the same angles. Okay, so I'm going to draw this as best I can. So you have this pentagon here. And all of the side lengths here are exactly the same. Okay. And it has a radius of 8. So remember, a radius is the length from the center to one of the vertices. So that length there is 8. And the question is, what's the apothem? So let me change up the color. So the apothem is a length that is from the center and is perpendicular to one of the sides. So this dotted line here, we'll label it little a for the apothem. And you can see here that we have limited amount of information. But one of the things we need to use is the other information that's given. So regular, again, means all sides and all angles are the same. And what that also means is that the central angle is the same. So, oh gosh, that was terribly drawn. That should be a straight line there. And let's just label this A, B, C, D. Let's put this dot here, D. Okay. So A, B, and BC are the same. They are both 8. And the central angle, the measure of angle ABC, is 360 divided by the number of sides, in this case 5. So we're going to get 72 degrees. Okay, so that big angle there, the red one, is 72. Now the blue angle, this little one in here, is just half of that. So the measure of angle ABD is 72 over 2, or 36 degrees. Okay. So I'm going to redraw, I'm just going to extract this picture as best I can. So this is 8, this is A, big A, this is little a, that's my apothem here that I'm looking for, and I know that this angle up here is 36 degrees. Okay. So to solve for A, I can use the trig ratios. This is going to be the adjacent length because it's touching the angle. So I'm going to use cosine. Right? Cosine is adjacent over hypotenuse of 36 degrees is equal to A. That's my adjacent length, and the hypotenuse here is 8. So multiply both sides by 8, and I get 8 cosine of 36 is equal to A. All right. Now I'm not going to get a perfect answer, so we'll have to round. And this turns out to be about 6.472 units is equal to the apothem. Now that we took care of the apothem, now let's talk about the perimeter. So this point down here, I think I labeled it D, right? So that corresponds to this point. If I want to find the perimeter, that's the length all the way around the pentagon. So I can also make good use of the information that I have. To find this length here, AD, I need to use the sine ratio. So sine of 36 degrees is equal to AD over the hypotenuse, which is 8. So 8 times the sine of 36 is equal to AD. Okay. Now, normally I would type this into a calculator and get my answer, but this is not going to be my final answer because I need to find the perimeter. Okay. So the perimeter is the length all the way around. So it's AD, AD again, AD again, AD again, AD again, here, 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 here. All of those green lengths there are going to be identical to each other. So we can set it up this way. Okay, the perimeter is equal to 5 because that's the number of lengths there are, number of the side lengths there are in the entire pentagon, times 2 because for each of these side lengths you have 2 of the small green lengths that we just found here, times the length of the small pieces, 8 sine of 36 degrees. So putting all that into a calculator, we end up with approximately 47.023. So our apothem is 6.472 and our perimeter is 47.023. So there you have it, an example of how to use the information that we have so far, knowing that it's regular to find the central angle, breaking this down into small right triangles, and then finding the area of the small right triangle, and then the side lengths, excuse me, and then multiplying it out. As always, keep working hard, ask for help. Do not hesitate to ask for help when you need it. Thank you for watching and have a wonderful day.